Hello viewers, welcome again to today's lesson. This is the solution space, the platform where mathematics is made easy and simple for everyone to understand and to enjoy. In this video, I want us to continue with the rationalization that I started with you in the previous videos. In the previous videos, we started learning about rationalization under the topic said, and we did a detailed explanation on it and we solved some examples on it as well. And I hope you all understood it and you enjoyed the lesson as well. So in this video, I want us to continue and handle another aspect of the rationalization where you have a fraction in which the denominator contains two terms. Okay, so in the first video, which is the previous videos, we handled questions where the fraction given for us to rationalize, you see that the denominator contains only a single term. That is what we did in the previous videos. All the examples that we solved, the fraction given for us to rationalize, you see that the denominator was just a single term. Okay, but in this video we are looking at a situation where we are given a fraction to rationalize, okay, where the denominator contains two terms, okay, or the denominator is a binomial expression. That's what I want us to look at in this video. And I will advise that you do well to watch the previous video because the previous video lays the foundation, the basic knowledge and understanding that you need to get about rationalization. I've done all those explanations in the previous video, so please do well to watch the previous video so that you can get a good foundation to be able to handle this session as well. And please don't forget to like the videos and also share them after watching. And if you are watching for the first time, please do well to follow the page as well. Now let's go ahead and handle the example 1 that I have on the board. So example 1, it says simplify 1 over 4 minus root 5. Okay, so you can see that this is an example where we have the denominator of the fraction containing two terms. Okay, so this is one term, this is another term, so it contains two terms. Okay, so these are the type of questions that we are going to look at in this video. Okay, but before we handle the example that I have on the board, I have to do some explanation, okay, using other examples, and when you get the understanding, we can proceed and solve the example that I have on the board. Okay, so now for us to be able to rationalize questions of this nature, okay, we need something else. Okay, the knowledge on conjugation of said is very important. Okay, so I'm going to teach you about conjugation of said, okay, because without your knowledge on conjugation of said, you cannot rationalize questions of this nature. Okay, so let me explain what conjugation of said is to you. Okay, so when we say the conjugate of a said, it's very simple. It's not difficult at all, so just follow the explanation and you are going to get it. Okay, so assuming I have so let me write the word down for you. Okay, so this is the word, the conjugate. Okay, the conjugate, okay, of a said. Okay, so conjugation of said, okay, or the conjugate of a said. Okay, so now when I have something like this, let's say I have root a minus root b. Okay, so now this is an expression that contains said. Okay, so now the conjugation of a given said, okay, or the conjugate of a said simply means that having root a minus root b, for you to conjugate it, it means that repeat the same thing, but the sign it has in between them, change it to the opposite. Okay, let me go over one more time. Okay, so when we speak about the conjugation of a given said, okay, so for example, having root a minus root b, and I ask you what is the conjugate of this expression, okay, this said that I've written on the board, what is the conjugate of it? It just means that you repeat the same thing and the negative sign you change it to positive. That's all. Are you getting it? So if here was to be positive, would have changed it to negative. Okay, that's it. So for me to get the conjugate of root a minus root b, the conjugate of this is going to be root a plus root b, and that is the conjugate of this set I have on the board, which is root a minus root b. The conjugate of it is root a plus root b. Okay, so you change the sign it has to the opposite, and that is all. Okay, so I hope the explanation is clear enough. So let me take another example and use it to explain it to you. So assuming I have root a plus root b, and I ask that what is the conjugate of this, okay, this set. Okay, so I have root a plus root b. We want to get the conjugate of it. So the conjugate of this simply means that repeat the same thing, but this sign change it to the opposite. So it is positive, so we'll change it to negative. So that is the conjugate of root a plus root b. Okay, so the conjugate of this is going to be root a minus root b. Okay, I hope the explanation is clear enough up to this point. Okay, so let me use other examples to explain it to you, okay, for you to get a better understanding of it. So I'm going to clean this one from here. Okay, so let's try another example. Let's say I have 2 minus root 3, okay, and I ask you what is the conjugate of this. Okay, this expression that I've written on the board, okay, which contains said, what is the conjugate of it? It simply means that repeat the same thing, then you change the sign in between them to the opposite. The sign in between them is negative, so we change it to positive, and that becomes the conjugate of 2 minus root 3. So to conjugate this one, our answer is going to be 2 plus root 3. Okay, and this is our answer for writing the conjugate for 2 minus root 3. Okay, so that's it. So very simple. Let me do another example with you. So assuming I have root 3 plus root 2, okay, root 3 plus root 2, and you are being asked to find the conjugate of this root 3 plus root 2. The conjugate is simply going to be root 3 minus root 2. So you repeat the same thing, but the sign in between them, you change it to the opposite, okay, because it is positive here. When we change it to the opposite, it becomes what? Negative. Okay, so this is the conjugate. The root 3 plus root 2, its conjugate is root 3 minus root 2. I hope the explanation is clear enough up to this point. Let's try the last example, okay, then we proceed. Okay, so now if I have, let's say, 2 root 3 minus, let's say 5, and I want the conjugate of this. Okay, so this is said, okay, so we want the conjugate of this, which is 2 root 3 minus 5. We want the conjugate of it. So the conjugate of this said, okay, is simply we repeating the same thing, but the sign in between them, we change it to the opposite. It is negative, so we change it to positive. Okay, so the conjugate of 2 root 3 minus 5 is going to be 2 root 3 plus 5. Okay, and that is the conjugate of 2 root 3 minus 5. It is 2 root 3 plus 5. Okay, so that's it about conjugate. Okay, because we are going to apply that knowledge to be able to simplify the question that we have on the board. Okay, I hope the explanation is clear enough up to this point. So I'm going to clean this one so that we can proceed. Okay, so we've learned about conjugates. Don't forget about it. We are going to apply it to be able to solve the question that I have on the board. Okay, so now the question that I have on the board, example 1, it says simplify 1 over 4 minus root 5. Okay, so now simplifying this one, it means that we need to rationalize it. Okay, so I've explained what rationalization is to you in the previous videos. Okay, let me just do a recap of it. Okay, so when given a fraction like this and you are being asked to rationalize, it simply means that, you see, you can see that the denominator of the fraction, it contains a square root sign, or it contains a z. Okay, so the process of making sure that there's no more z or there's no more square root at the denominator of the given fraction, that process is what we refer to as rationalization. Okay, so in simple terms, when you have any given fraction, okay, which has z at the denominator, you are being to rationalize. It means that we have to make sure that there's no more z at the denominator of that fraction, or there's no more square root sign at the denominator of that given fraction, and that process that we go through to arrive at the answer, which there will be no more z at the denominator of the fraction, or there's no more square root sign at the denominator of the fraction. That process is what we refer to as rationalization. Okay, so we've done a lot of examples on it in the previous videos. Okay, so please do well to watch the previous videos so that you can easily handle this session as well. Okay, so now let me write an example which is similar to this and use it to explain it to you before we proceed. Okay, so now assuming I have something like this. Okay, let's say I have 1 over 2 minus root 3. Okay, I'm being asked to rationalize this or simplify this one. Okay, so I've explained to you that when we are being asked to rationalize this, is the same as you being asked to simplify this one. Okay, so because simplifying this one, the only approach you can use to simplify this one is to go through the process of rationalization. Okay, so it's either you are being asked to rationalize this or you are being asked to simplify this one. It's the same thing, you go through the same process. Okay, so now don't forget I've taught you conjugate. Okay, so now you have to be able to know the conjugate of the denominator. Okay, because what you are going to do to be able to simplify this one is that you are going to multiply both the numerator and the denominator of this same fraction by the conjugate of the denominator. Okay, so this denominator that we have there, which is 2 minus root 3, we are going to find its conjugate, and we are going to use that conjugate to multiply the numerator of the same fraction and also the denominator of the same fraction. That is the step to go through. Okay, so now the denominator we have here is 2 minus root 3. Okay, now the conjugate of 2 minus root 3 is going to be 2 plus root 3, and I just explained that to you. Okay, that to find the conjugate of this, you just change the sign in between them to the opposite. It is negative, so we write this as positive. So the conjugate of 2 minus root 3 is 2 plus root 3. Okay, I hope you understand it. So this is the conjugate of the denominator that we have here. So we are going to multiply this same fraction, okay, both the numerator of the fraction and the denominator of the same fraction by the conjugate, which is the 2 plus root 3. Okay, so let's go ahead and simplify this one. So to simplify this one, okay, it's going to be, I'm going to repeat my 1 over 2 minus root 3, okay, multiplying, okay, we multiply it by the conjugate of the denominator, and the conjugate of the denominator is going to be 2 plus root 3 all over, okay, we multiply both the numerator of the fraction and the denominator of that same fraction by the conjugate. Okay, so we've done for the numerator, we've multiplied the numerator by the conjugate. So this denominator also, we are going to multiply it by the conjugate, which is 2 plus root 3. Okay, so this is how you go about it. I hope the explanation is clear enough up to this point. So now the next step is that we have to multiply what you have there. So the numerators will multiply and the denominators will multiply as well. Okay, so we are going to do our 1 times what we have here, and this 2 minus root 3 times what we have here. Okay, so let's go ahead and do it together. So I have my 1 into bracket, okay, 2 plus root 3, okay, because the bracket means multiplication. Okay, so I have my 1 multiplying 2 plus root 3, so this is the 1 multiplying the 2 plus root 3 all over then this term, okay, the whole of this term will also multiply the whole of this term. Okay, so we are going to put each of them into bracket. Okay, so it's going to be 2 minus root 3, okay, multiplying 2 plus root 3, okay, because the two brackets put together like this means they are multiplying. I hope the explanation is clear enough up to this point. All that we did is to multiply the numerators and multiply the denominators. So let's go ahead and simplify further. So this one will open its bracket. Okay, so let's go ahead and do that. Okay, so 1 times 2 gives 2. Okay, so let me continue from this side. 1 times 2 gives 2 plus 1 times positive root 3 gives positive root 3 all over. Now when you come to the simplification of the denominator, we are going to apply the knowledge that we've had on the multiplication of two binomials. Okay, so we've done this one in the previous videos. Okay, so we are going to maintain the last bracket, and each term in the first bracket will multiply the last bracket. So when I take the 2 here, it will multiply the last bracket. Then I'll take the minus with 3 here, it will also multiply the last bracket. That's how you simplify it. And we've done a lot of examples on this in the previous videos. That's why I keep on encouraging you to watch the previous videos, because we've done this in the previous videos and we are just applying that knowledge here. Okay, so let's go ahead and simplify the denominator. So when I take this 2 here, it will multiply the last bracket, which is 2 plus root 3. Okay, then I'll take this minus root 3 also. It will multiply the last bracket, which is 2 plus root 3. I hope you understand up to this point. Okay, so this is what you have to do. Okay, now the next step is to just repeat the numerator, then the denominator, we open our bracket. Okay, so let's go ahead and do that. Okay, so now I'm going to repeat my 2 plus root 3, which I have at the numerator. Okay, all over, then the denominator, we are going to open our brackets. 2 times 2 gives 4. Okay, and 2 times positive root 3 gives plus 2 root 3. Okay, and this minus root 3 will also open its bracket. So minus root 3 times 2 gives minus 2 root 3, and minus root 3 times positive root 3 will give negative root 9. Okay, or negative root 3 all squared is the same thing. Okay, so now let's go ahead and simplify further, because we can still simplify further, we are not done. Okay, so let me continue from this side. Okay, I hope you can see from the board, so I want to continue from this side. So I'm going to repeat the top, which is 2 plus root 3. Okay, all over. Okay, then the down one, what we have here is 4 plus, you can see that we have positive 2 root 3 here, and we have negative 2 root 3 here. They are like terms, so we can simplify. So positive 2 root 3 minus 2 root 3, they will cancel away, so it will be left with 0. So what will be left here is minus root 9. But we know the answer for square root of 9. The answer for square root of 9 is 3. So we are going to write the answer for square root of 9 here. So repeat your minus, which is here, because this and this cancel away. We are left with the minus root 9 here. So repeat your minus. Square root of 9 is 3. So you bring your 3. Okay, so now you see that we are having 2 plus root 3 all over 4 minus 3 is 1. Okay, so you see that there's no more said at the denominator of the given fraction, which is 1 over 2 minus root 3. So this is our final answer. We've simplified it. Okay, so this is the process. You can see that there's no more square root sign at the denominator. Okay, or there's no more said at the denominator. So that is the correct approach to go. Okay, so if you do any rationalization and still you are having a square root sign at the denominator or a said at the denominator, it means you've done something wrong. Okay, so after rationalizing, you will not have any square root sign at the denominator or a said at the denominator. So you can see we are having 2 plus root 3 all over 1. Okay, which we can still write as 2 plus root 3. Okay, so it's the same thing. So this is our final answer, which is 2 plus root 3 all over 1, which is the same as 2 plus root 3. Okay, so you can just write it again as 2 plus root 3 as your final answer. Okay, and that is we rationalizing or simplifying 1 over 2 minus root 3. I hope the explanation is clear enough up to this point. So with this understanding, we are going to solve the example 1 that I have on the board. So let's go ahead and solve the example 1 that I have on the board. So I'm going to clean this one from here, and I hope the explanation is clear enough and you understood it as well. So let me clean this one, and so that we can have enough space to simplify the example 1. So example 1, it says simplify 1 over 4 minus root 5. Okay, so let me write down my solution and let's do it together. Okay, so now I have 1 over 4 minus root 5. Okay, we have to rationalize this one, and I've explained to you that for us to rationalize this one, we are going to multiply both the numerator and the denominator of that same fraction by the conjugate of the denominator. Okay, so we have 4 minus root 5 at the denominator of this fraction. Okay, so the conjugate of it is going to be 4 plus root 5. To get the conjugate, you just change the sign to the opposite. It's negative, so we change it to positive. So we are going to use 4 plus root 5 to multiply both the numerator and the denominator of that same fraction. Okay, so let's go ahead and do it. So I'm going to write my equal sign, then I'll repeat my 1 over 4 minus root 5. Then we multiply both the numerator and the denominator by the conjugate of this denominator. Okay, so it's going to be times 4 plus root 5 all over 4 plus root 5. Okay, so this is how to handle it. Okay, so now let's do the multiplication. We are going to multiply the numerators and we are going to multiply the denominators as well. So it's going to be 1 times, okay, the bracket means multiplication. So 1 times 4 plus root 5, bracket close, okay, all over. Then this one also is going to be 4 minus root 5 multiplying 4 plus root 5. Please, you put them into brackets like this. Other than that, you make a mistake, okay, or you get confused about it. Okay, so put the two terms into brackets like this. That's the right way to go about it. Okay, so now let's go ahead and open our bracket. Okay, so I'll have 1 times 4, it gives me 4, plus 1 times root 5, it gives me root 5 all over the denominator. How to simplify the denominator is to apply the multiplication of two binomial principle. Okay, so we are going to maintain the last bracket, then each term in the first bracket will multiply the last bracket. Okay, so when I take this form, it will multiply the last bracket, which is 4 plus root 5. Okay, so 4 plus root 5. Then I close my bracket. Then I'll take this minus root 5 also. It will multiply the last bracket, which is 4 plus root 5. Okay, and actually there's a short way of simplifying the denominator, which I'll teach you in other videos. Okay, so there's a very short way you can apply, okay, which is the difference of two squares approach. Okay, because I've not taught you difference of two squares, that's why I'm not saying anything about it. Okay, but we are going to go ahead and go through this process and we are going to get the same answer. Okay, so let's go ahead and simplify further. Okay, so I'm going to repeat my, let me continue from this side. Okay, so the numerator, I have 4 plus root 5. Okay, 4 plus root 5 all over, I hope you can see from the board. Okay, so now we are going to expand what you have at the denominator. We are going to open the bracket. Okay, so the 4 will open its bracket, the minus root 5 will also open its bracket. Okay, so let's go ahead and do it together. So 4 times 4 here gives me 16, and 4 times root 5 gives me plus 4 root 5. I hope you agree with me. Okay, then the minus root 5 will also open its bracket. Okay, so minus root 5 times 4 gives me minus 4 root 5. Okay, I hope you agree with me. Okay, and we have minus root 5 times positive root 5. It will give me negative root 25 or negative root 5 all squared. It's the same thing. I hope you can see it from the board. Okay, so here's what we did. 4 times 4, 16. 4 times root 5, it gives 4 root 5. And minus root 5 times 4 gives minus 4 root 5, and minus root 5 times minus root 5 gives minus root 25. Okay, so let's go ahead and simplify further. Okay, so I'm going to repeat my 4 plus root 5 at the numerator. Okay, all over the denominator I have my 16. You can see that this 4 root 5 and this minus 4 root 5, they are like terms that we can simplify. Okay, so let's simplify them. So this positive 4 root 5 and this minus 4 root 5, they'll cancel away. So we are left with minus square root of 25, and square root of 25 is 5. So you write your answer 5 there. Okay, so let's go ahead and simplify further. So I have my 4 plus root 5 all over 16 minus 5. Okay, 16 minus 5 gives 11. Okay, so you have 4 plus root 5 all over 11. You can see that there's no more said at the denominator of it. Okay, so there's no more square root at the denominator of this, so it means we've rationalized it, okay, or we've simplified it. Okay, so this is the process to rationalize questions in which the denominator of the fraction, okay, is a binomial expression, okay, or it contains two terms, okay, of this nature. Okay, this is what to do to be able to rationalize it or simplify it. So this is your final answer, and don't forget that anytime you do rationalization, okay, always the denominator will no longer contain a square root sign, or it will no more contain a surd. So immediately you do it and you see that your final answer, you are still having a square root sign at the denominator, it means you are wrong. Okay, so then you need to quickly change your solution. Okay, so this is the final answer, and I hope the explanation was clear enough and you understood it as well. I'll be back on your way again in another video whilst you solve more questions on this. Please don't forget to like the video and also share the video as well. And if you are watching for the first time, please follow the page as well. Bye bye.